In 1964, Arno Penzias and Robert Wilson serendipitously discovered the cosmic background radiation, an omnidirectional signal in the microwave band. Their discovery provided substantial confirmation of the Big Bang predictions by Alpher, Herman and Gamow around 1950. Through the 1970s, the radiation was found to be approximately consistent with a blackbody spectrum in all directions. This spectrum has been redshifted by the expansion of the universe, and today corresponds to approximately 2.725 K. This tipped the balance of evidence in favor of the Big Bang model, and Penzias and Wilson were awarded the 1978 Nobel Prize in Physics. The surface of last scattering corresponding to emission of the CMB occurs shortly after recombination, the epoch when neutral hydrogen becomes stable. Prior to this, the universe comprised a hot dense photon baryon plasma sea where photons were quickly scattered from free charged particles, peaking at around 372 plus or minus 14 kyr. The mean free path for a photon becomes long enough to reach the present day and the universe becomes transparent. In 1989, NASA launched COBE, which made two major advances. In 1990, high-precision spectrum measurements showed that the CMB frequency spectrum is an almost perfect blackbody with no deviations at a level of 1 part in 104, and measured a residual temperature of 2.726 K. More recent measurements have revised this figure down slightly to 2.7255 K. Then in 1992, further COBE measurements discovered tiny fluctuations, anisotropies, in the CMB temperature across the sky, at a level of about 1 part in 105. John C. Mather and George Smoot were awarded the 2006 Nobel Prize in Physics for their leadership in these results. During the following decade, CMB anisotropies were further investigated by a large number of ground-based and balloon experiments. In 2000-2001, several experiments, most notably Boomerang, found the shape of the universe to be spatially almost flat by measuring the typical angular size, the size on the sky, of the anisotropies. In early 2003, the first results of the Wilkinson microwave anisotropy probe were released, yielding what were at the time the most accurate values for some of the cosmological parameters. The results disproved several specific cosmic inflation models, but are consistent with the inflation theory in general. The Planck space probe was launched in May 2009. Other ground and balloon-based cosmic microwave background experiments are ongoing.